learning to love de-identification in biomedical research. But de-identification is a really big, ugly word that I just find confuses people. So I just like to say that this is a talk about how I love privacy. Because if I give you enough time, enough effort, enough incentive to do so, and enough money to pull this off, chances are you could break into any system, which implies that you should be able to measure what's actually going on in terms of the amount of protection that you're putting into the system, because no system ends up being perfectly secure or private. Where we have been trying to push the field over the last couple of years has been to get people to recognize that there's a massive difference between what is possible in terms of demonstrating that there's a crack in the system and what is possible in terms of how you actually go about realizing that and putting that into a manner that actually leads to harm in the system. To really understand what it is that we're talking about in terms of how you measure risk and how does this relate to the status of a de-identified data set, you have to understand what de-identification is and how it's actually defined. This all dates back to this notion of a quasi-identifier. And quasi-identifiers are these things that you can use to distinguish an individual and track them across time and space. And I call this the quasi-identifier conundrum because the quasi-identifier conundrum brought us HIPAA as it currently stands today, which is going to be an important thing to talk about. And in HIPAA, it basically says that this is information that does not identify an individual, and there's no reasonable basis. There's a lawyer in the room, right? There's no reasonable basis that the information can be used to identify an individual. So under HIPAA, you then had several different strategies that they offered. One was what was called safe harbor. That's what I was alluding to before. And under safe harbor, here's where the prescription comes in. They say, take out these 18 things. These are naughty bits. We don't like them. Remove them from the data. And then you need to certify that you have no actual knowledge that this information could be re-identified. So we started to try to step beyond this and say, all right, how do we start doing these statistical techniques? How do we actually go about measuring risk in the system? Because it's not exactly what's being done. But risk in this situation can kind of be split into two parts. The one that most people look at is the second one that says, what's the probability of a re-identification given the attack is going to be committed? You bring somebody to the data and you say, hammer on the data and go try and find somebody. So what's actually the risk associated with sharing data in the safe harbor format? What matters is that risk is semantic, because every different state, every different data set brings about a different amount of risk. And if you go and you use the federal government's blanket model for remove X, remove Y, remove Z, everybody puts their data in different risk. The central dogma here is that that was just measuring uniqueness. You actually have to commit the exploit. To commit the exploit, you need a way of linking your de-identified to an identified record. You actually need to get across that bridge. Right? We've seen some ways in which you can do it. To what extent will somebody actually do it? When you try to actually commit the identification using the information that's available to you, what you see is that this is the graph I showed you before with limited data sets. When you try to actually link this for an identification, like people have done in the past, the risk drops by a factor of 3 to 10 really quickly. And it depended on the state, as I mentioned. What I've shown you so far is that you can get risk measures. Now you have to say, so what's the incentive structure? That's where a lot of our research is going now. What we're doing now is we're modeling the system as a publisher. We're a publisher. We have a certain utility for sharing the data. We want to keep it in its greatest level of fidelity, its greatest detail. And there's going to be a certain amount of risk associated with sharing it at that level, depending on what the adversary can do. Now, 3 different things here that I'm showing here. The one that's really notable for us is this green one. And this one is called the safe harbor no attack. In other words, you can have a system in which the data is no different than the safe harbor style, if you want to communicate that to your IRB. But you can show that the incentive structure is such that your adversary will always end up in a negative payout situation, such that they never choose to attack. So you push data out into the world, you will get benefit from putting the data out into the world, and assuming rational behavior, not everybody's rational, then you're going to end up being protected. One thing you have to recognize, de-identification, it's not a panacea. There always is a risk of re-identification. Always, there's no matter what you do, you can't get rid of this. The risks, these, however, exist in many different settings.